Hello everyone. Today we're going to take a look at still using the product and quotient rule, but in different situations. At the very end, I'll show you, and I'll have it posted as a separate PDF, but the solutions to GIF 3.3 Part 2. And now if you have any questions on 3.3 Part 1 or anything else we were doing over the last week, please make sure you attend the Zoom meeting today and let me know. All right, so off of page 120 in your book, I'm just going to read the directions for you, but you can copy everything down here. There's 4 parts that we're going to go through. But the directions here say, suppose u and v are functions of x that are differentiable at x equals 2, and that u of 2 is equal to 3, u prime of 2 is equal to negative 4, v of 2 is equal to 1, and v prime of 2 is equal to 2. We're going to find the values of the following derivatives at x equals 2. So make sure you copy down everything that's given here. And keep in mind it's at x equals 2. So the idea here for A is just to be able to read all of this notation, understand what it means. So part A is asking us to take the derivative of the product of u and v. So we're going to use a product rule here. So again, just in the easiest way possible, I'm going to write that out, which is uv prime plus vu prime. Now keep in mind this is really saying u of x times v prime of x plus v of x times u prime of x. And again, here x is equal to 2. So when I go to write this, I'm taking u at 2, u at 2 is 3, times v prime of 2 is 2, plus v of 2, which is 1, and u prime of 2, which is negative 4. So I'm going to get 6 plus a negative 4, which will just give me 2. All right, part B, what rule do you think we're going to use here? What is it saying? We have a quotient here. We're taking the derivative of a quotient. So in this case, I'm still going to think about when I go to write this out, I'm going to say to myself the low d high minus the high d low over low low. And because we have u on the top and v on the bottom, it matches how I was first introducing this to you. So if I go low d high, so that's my low is v, d high is u prime, minus high d low, so that's uv prime, all over v squared. And that was the second way that I had this written out without like the v of x and u prime of x. So again, looking at these values, so v of 2 is 1, u prime is negative 4, u of 2 is 3, v prime is 2, all over v squared, which will be 1 squared. So we end up getting a negative 4 minus 6 over 1, which is just negative 10. All right, now for C, look very carefully at it. What do you notice? It's still the derivative of a quotient, but this is why it's not always best to remember like the u's and the v's in that order, but the low and the highs, because here the v and u are switched. So it's very easy to get that confused if we stick straight with the first and the second way that we looked at the quotient rule. All right, so here, again, if I go low d high, my low is u, d high is v prime. Now I'm minus. And my high, which is v, d low, all over low low, so that'll be a u squared. So we have low d high minus high d low over low low. So here, u of 2, again, is 3, v prime is 2, v is 1, and u prime is negative 4. And again, u is 3 squared. So we're looking at 6 plus a 4 over 9, so 10/9 for this one. All right, now D's a little different. Again, because this is with respect to x, we're going to have to write this out in a special way. And then I'm going to explain a little part afterwards as well. All right, so as I go through this, when I go to take the derivative of my first term, I'm just going to have a 3 times u prime. Again, I'm going to explain that separately here in a little bit. Minus my derivative of this is going to be minus a 2v prime. And then I can write this as 2 times uv prime like this. So it's 3 times the derivative of u minus 2 times the derivative of v, and then plus 2 times the derivative of uv. Now, I'm going to show this off to the side. If I was just looking at the derivative of 3u over dx, I'm going to call, because it's already a u, I'm going to call this u, so I'm going to call this v. And again, it doesn't matter the order. When I'm using the product rule, the order really doesn't matter. I'm just going to have the first factor alone, nothing is done to it, times a derivative of u, so that becomes a u prime. plus, then I'm going to have my second part here, which is left alone, times my derivative of the other factor, which will be a 0. So I just get 3u prime. So when we're taking derivatives with respect to other variables, this is how we want to write it. So it just becomes a 3u prime. So very similar to the minus 2v prime. Now to make life a little bit easier, we found this in part A. So now this will become 3 times u prime of 2, so that's going to become a 3 times a negative 4, minus 2 times the v prime was 2, and then our answer to part A was just 2, because we already found this here. So we're going to say 2 times 2. So we're going to get a negative 12 minus 4 plus 4, and we just end up with a negative 12. So in this case, we just wanted to write it sort of out this way, and it makes it a lot easier. Now, we could have still done the product rule here, and we would have had a couple more terms, but we still would have ended up with negative 12. All right, so here's a slightly different question as well. We want to determine the point or points at which the graph of the function has a tangent line with a slope of negative 3. So here's f of x is equal to x squared over x minus 1. We're going to do all of this without a calculator until the very end. We're going to check our work. So right now we have to find the slope of the tangent line, which is the same as f prime of x. So let's go ahead, and because this is a quotient, there's no other way to simplify this. We have to use the quotient rule. So pause the video, go through and do that, and we'll see what you come up with. All right, so if you were using the quotient rule, we have low, which is x minus 1, d high becomes a 2x, minus high, which is x squared, d low becomes a 1, all over x minus 1 squared. So if I distribute here, I'm going to get a 2x squared minus a 2x minus x squared, all over x minus 1 squared. Simplifying that, we get an x squared minus 2x, all over x minus 1 squared. So I'm just going to leave it this way for right now. Now we want to know when this is going to equal 3. So when the slope of the tangent line, rather negative 3, is going to equal this negative 3 here, we're going to say x squared minus 2x all over x minus 1 squared. When will that equal a negative 3 or negative 3 over 1? So we can cross multiply here. So by doing that, I'm going to get a negative 3 times the quantity x minus 1 squared equals x squared minus 2x. I can expand this right here. So I'm going to get an x squared minus 2x plus 1 equals x squared minus 2x. Distribute the negative 3. We're going to get a negative 3x squared plus 6x minus 3. We'll get everything to one side, set it equal to 0. So I'll move everything over to the right. So we're going to get a 4x squared minus an 8x plus 3. And we'll factor this. No GCF here, so let's just do 2 sets of parentheses. I think 2x and 2x are going to work. We could do a 3 and a 1. This will give us a 6 and a 2. Our signs are the same. They should both be negative. So we're going to get x is equal to a 3/2 and x is equal to 1/2. But we're not done yet. These are just the x values. We want the entire points. So we need to find the y values at both of these x values. All right, so again, our function was x squared over x minus 1. So we want to find f of 3/2, and we want to find f of 1/2. So pause the video, go ahead and do that. All right, so f of 3/2, if we square this up top, this is going to be 9/4 over 3/2 minus 1. A couple ways we could do this. We can multiply everything by 4 if you want. So we're going to get 9, change that color, and then this will become a 6 minus 4, so we're going to get 9/2. So we have one ordered pair at 3/2 and then 9/2. Over here, if I take 1/2 squared, that's going to be 1/4, and then I have 1/2 minus 1. Now you could clear denominators here. If not, this isn't too bad. It's 1/4 over a negative 1/2. And here we could multiply top and bottom by a -2 rather. And we get a -1/2. So the other ordered pair is 1/2, -1/2. So these are our answers. These are the 2 points. Now we're going to check on the calculator. So please go to a graphs page on your calculator. All right, so we just want to go ahead and graph. We have x squared over x minus 1. So this is what we're looking at. Let's go ahead and plot the points. So let's go to menu 5, 1. Let's go to 1/2. Hit enter, and let's mark that spot. And then let's go ahead and type in 3/2. And let's mark that spot. So just hit enter again. All right, so now hit escape. And I'm just going to move these points out of the way for a little bit. All right, let's go to menu. We want to go to geometry, points and lines, and then tangent. So I want to put a tangent line right here. And again, what's nice about this, hit escape because we want to move this out of the way. Here's the equation of my tangent line. And we're going to do the same thing up here. So let's go back to menu, geometry, points and lines. Let me go back here. And then tangent. I want to go up here to this point, put another tangent line in there, hit escape. That way we can move the equation out of the way. But if you notice, because the question here was, let me go back. We want to determine the point or points at which the graph of the function has a tangent line with a slope of -3. So if I go back to my graph, this slope over here as well was -3, slope of the tangent line. If you can tell, they're parallel. So at these 2 points, that's what we answered here. We didn't just find the x value, we had to find the ordered pair. So once we have the x value, we have to substitute it back into the function to find the points. And I just sort of copied this here, highlighting the slopes of the tangent lines. They're both -3. All right, so like I said, I'll have a separate PDF of the Gift 3.3 Part 2 answers. I also want you to work on page 120, 23, 27, 32, 34, and 35. This is just a reminder there's going to be a test Friday over the first 3 sections of Chapter 3, the gifts, the homework worksheets included. The entire thing is no calculator. I'll let you know over the next couple days how many problems to expect, the point values roughly. Should be about 40 to 45 points. Do the Inspired Doc 3-4, which I'll make another video for, including rates of change. Test topics, here's what you can expect. So like I said, between 40 and 45 points, I'll have it narrowed down to how many problems over the next couple days. So even though we know the shortcuts, still go back over the limit definitions of derivatives. Still might be your choice, but I'm going to want you to use one of these. So at a point A, so remember that was f prime of A is the limit as x approaches A of f of x minus f of A over x minus A, or the one that has the limit as either h approaches 0 or delta x approaches 0. Know the 4 types, the 4 flavors of non-differentiability. Given the graph of a function, graph the derivative. Use all the rules we've talked about so far, power, product, quotient, and then just the polynomials, which is still an extension of the power rule. Still be able to find the equation of a tangent line, normal line, and know the derivatives of sine and cosine. All right, like I said, I'll have a separate PDF of this. I'll still scroll through it so you could check this way if you want to pause a video. So especially if you have a question on number 6, going through the Inspire doc, section 3.3 will be very helpful. in explaining that. All right, so like I said, if you have any questions, please join the Zoom meeting later today, and hope to see you guys soon. Take care.